We're looking now at graphing inequalities. The first thing we're going to look at is what does it mean if I ask if I have a solution to an inequality. So for example, if I have following inequality, y is less than or equal to x minus 2 squared minus 3. And I asked you the question, is 3 negative 4 a solution to the above inequality? That means what? If it's a solution, it means that when we plug those values in, this would be a true statement. That's all it means. It doesn't mean the solution, it means a solution. Let's see if that's the case. We replace y with negative 4. Is negative 4 less than or equal to 3 minus 2 squared minus 3? Let's simplify that a little bit. Is negative 4 less than or equal to 1 minus 3, which equals negative 2? Well, the question is negative 4 less than or equal to negative 2? And the answer is yes. So this is a solution. Let's look at another example from the same equation or same inequality. Is 4, 7 a solution to that same inequality? Well, we check it in the same way. We say 7, is that less than or equal to 4 minus 2 quantity squared minus 3? Is 7 less than or equal to 2 squared minus 3, which equals 4 minus 3, which is 1? Is 7 less than or equal to 1? No. So this would not be a solution. Does that make sense? Okay, then there's one more thing I want to look at for inequalities. And that is, how do we graph an inequality? So if we have y is greater than x minus 4 cubed minus 2, this is related to the parent graph of y equals x cubed. And we looked at that in the last section. So we would do a little sketch of y equals x cubed. It's like this, right? Now, how is this shifting that? How is this changing it? Well, if we're going to the right 4 spaces, and we're going down 2. So the equation y equals x minus 4 quantity cubed minus 2 can be sketched out like this. We go over 4 on the x-axis in the positive direction, and we go down 2. So it would be roughly like this. Oops, let me try this one again. It would be roughly like this, right? That's related to the parent graph by being shifted over 4 in the positive x direction and shifted down 2. All right? Now, but we're not going to graph. This says y is greater than. In order to indicate y is greater than, we need to do the following. We need to make a dashed curve, which indicates not or equal to. All right? And the last piece that we need to do with graphing this is it's not just the borderline that's important, or the curve that's important. It's what? What are we missing here? If we have a greater than sign, we have to shade in one direction or the other. We can shade above, right? You're saying shade above. Well, Abby's saying shade above, which happens to be correct. We can actually test if that's the correct direction by how? How would we test if that's the correct direction? Michael. Right, we take any point, and the easiest one to test is we say, is 0, 0 a solution to that inequality? Well, if that was the case, it would be, is 0 greater than 0 minus 4 cubed minus 2? And that is 0 greater than negative 4 cubed is negative 64, so this is negative 66. So the answer is yes. If a point in the region we're looking for is in the solution set, and we've done our algebra correctly, then that entire region is the solution set.